Hey, good afternoon, and thank you for joining us for this Apparatus and Pure Storage webinar. Before I hand things over, I'd like to introduce our presenters, Avi and Kyle. Avi Nayakas joins us from Pure Storage headquarters in Mountain View, California. He is a product marketing manager for Pure Storage, focusing on Tier 1 applications like Oracle, Microsoft SQL Server, SAP, etc. His previous experience includes VMware, where he was a solution owner and chief evangelist for virtualization of mission-critical applications, Cisco, where he was part of the business intelligence team working on predictive analytics models, and PayPal, where he was part of the marketing analytics team. Avi has been a frequent speaker at VMworld, vMugs, and vForums. Also presenting today is Kyle Nair, a lead database architect for Apparatus. Kyle is a Microsoft Certified Master for SQL and Data Platform. Kyle currently leads all SQL Server database projects at Apparatus. Over the course of his career, he has worked or consulted for hundreds of companies spanning from Fortune 100 to startups. Just one thing to keep in mind before I hand things over, that we will have time for questions and answers at the end of the presentation. So be sure to jot down any questions you have along the way, and we'll be sure to get those answered before the end of the hour. So now I'd like to turn it over to Kyle.
Thank you, Anne. One thing I always like to start out with is a little bit about me. First off, I always give a call out to my wonderful, magnificent wife. I'm proud father of 5. I'm the IndyPass Vice President here in Indianapolis. That's the local chapter for SQL Server. I'm working with SQL Server for a very long time. Started out as a developer and moved into the administrator role several years back. As Anne said, I am a Microsoft Certified Master for SQL Server 2008. I've been working as a DBA in the guts of SQL Server for the last several years, and I find myself being both a database automation enthusiast and evangelist. So as we get started here, and I'm going to hand it over to Avi to talk a little bit about Pure Storage, because before we really get into how it works with SQL Server, to get a background on the company and what they do.
Thank you very much, Kyle, and thank you for having me. It's always a pleasure to work with great partners like Apparatus. So I'm quickly going to give the audience an introduction into Pure, because I realize some of you may not have heard of Pure Storage. We were founded by 2 gentlemen, John Colgrove and John Hayes. Colgrove, or Cos as he's affectionately known inside Pure, was actually one of the founding engineers at Veritas. He wrote one of the first lines of code for Veritas Volume Manager. John Hayes, or Hayes as he's known here, was a part of the office of the CTO at Yahoo, working on distributed systems. So these 2 gentlemen came together with the idea that there has to be a better way to do storage, right? So if we were to start from scratch with today's technology, how would we architect storage? Essentially they came to the conclusion that, well, it has to be flash. Spinning disk is 1970s technology. If we were architecting a solution from scratch from today, we would do it with flash, of course. So that's essentially the mission of Pure Storage, to enable the all-flash enterprise. We are a rapidly growing company. We were founded, I think, in 2009, but as of today, we are over 600 strong, with industry veterans from companies like VMware, Cisco, EMC, NetApp, etc. We have a very robust investor community that's poured in over $470 million into Pure Storage. And we're working very hard to differentiate ourselves with our technology via patents. We've got over 150 patents in process right now. So our goal, essentially, is to build a better storage company. We are, I think, one of the fastest growing data center companies in history. And we've been able to achieve that by, number one, attracting the best people in the industry to Pure. We've been very careful in deciding whose money we accept in terms of investors. We only accept money from investors who are strategically aligned with our vision. Our goal is to also build a globally consistent company. The aim is that a customer in Tokyo will have the same exact experience with Pure as a customer in New York. Well, with that in mind, we've opened up offices in 12 different countries, and we've built a very, very strong partner network. We've also think that we have the best support in the industry, period. Our net promoter scores are almost 2 times that of the leading competitors or the leading companies in the industry. We're fanatical about support. Often we hear customers say that, well, I didn't even know there was an issue until the Pure support engineer called me. And often we're able to find issues that are not related to Pure in other parts of the stack and proactively tell customers that, well, for example, your server firmware is out of date. You probably want to update that. Finally, we think that we can differentiate ourselves not just by the technology or by the people, but by also the way that we conduct business through innovative programs, which actually solve a lot of the issues that customers face today when they're dealing with other infrastructure vendors. I'll talk a little bit more about that as we go along. But to give you an idea of what we do or what our products actually are, we have an all-flash enterprise array. As of today, those come in 3 flavors: the FA405, and FA stands for flash array, FA420, and the FA450. As you can see, we can scale from 40 terabytes all the way up to 250 terabytes. So essentially, there is a flash array for any application and any budget in the enterprise. The hardware that we have is extremely robust, but the secret sauce is really in the software. That's the Purity operating environment. This is where the magic really, really happens. So this is where we do the inline data reduction in terms of deduplication, compression, pattern removal, etc. This is where we basically build a resiliency into the product with Flash Protect. This is basically where we architect the snapshot technology, the replication technology, etc. And this is also where we basically ensure that Flash is treated the way that it's supposed to be treated. Unlike spinning disk, Flash is a completely different animal and should be treated that way. So we're very careful on how we basically write or read from the Flash media. Another way that we actually differentiate ourselves from the competition is that we offer our software for free. Well, not really for free, but it's bundled as part of the entire package. We will never nickel and dime you on the software. For example, with our latest release of Purity, Purity 4.0, we introduced replication. That came free. We did not tell customers, hey, that this is something that you have to pay for. This is just included as part of your upgrade from Purity 3.0 to Purity 4. So like I said, what we were built on is to basically ensure that customers never have to buy spinning disk ever again. Our goal is to remove spinning disk from all data centers. So the product that we've architected is 100% built on solid-state flash, MLC flash, which is essentially commercial-grade flash. Because of what we're able to do with the software layer in terms of data reduction, with inline deduplication, compression, and pattern removal, we found that we're actually able to come in at a cost that is comparable or less than the cost of disk. We fully realize that there are a lot of other parts in the data center, so we've architected the solution to be completely compatible with the existing infrastructure that you're currently running. And we actually believe that we are 10 times better in more or less every dimension compared to legacy storage, whether that be performance, reliability, ease of use and management, as well as efficiency in terms of power, cooling, space, etc. So let me take you on a little history lesson. So Flash has been around for a while now. If you were to ask a customer, hey, if all things being equal, what would you want to run your business on? Flash or spinning disk? They say, well, of course, Flash, right? I get the performance that I need. It's 100 times better than spinning disk, but I can't afford it. So that used to be the typical response from customers, saying that Flash was exponentially more expensive than spinning disk. It did not make sense from a ROI perspective. Because of these data reduction technologies, in terms of like deduplication, compression, pattern removal, etc., you're actually able to bring the cost of Flash at the cost of disk, simply because you need to store less data in the Flash media. So you actually get the performance of Flash without having to pay the exorbitant cost of Flash. And when I say exorbitant cost, I'm talking about the raw cost of Flash. So this slide essentially shows you basically how that evolution has taken place, how we're basically able to drive down the cost and the economics of Flash, where it is becoming a very, very appealing proposition for customers. In fact, most of our customers who have seen the power of the Pure Array say that they will no longer ever buy a legacy storage array ever again. And they're making plans to replace every spinning disk in their data center with Flash. But performance is only half of the equation. Especially when it comes to mission-critical applications like Oracle, SQL Server, SAP, etc., downtime cannot be tolerated. Downtime means, one of our customers told us that even a minute of downtime costs them hundreds of thousands of dollars. So this is a core design tenet of Pure Storage, non-disruptive everything. We will not tolerate downtime, whether it be planned or unplanned. So we've architected the array to be non-disruptive in terms of capacity expansion, performance expansion, hardware replacements, software updates. You can do all of these things with zero performance loss. But never believe a vendor who says that the product that we sell you will never go down. I don't believe that. Things happen. Acts of God happen. What differentiates the good vendors from the not so good vendors is how do you react when issues come up. For that particular reason, we have accumulated the best storage support people in the industry. We believe that we've built the best support technology in the industry as far as storage is concerned. We're extremely proactive in terms of remote management. So we actually monitor all of the arrays remotely to ensure that they're performing at the optimum level. And we have global consistency and partnerships with other vendors like Cisco, Oracle, etc., so that wherever the issue crops up in the stack, we can proactively work with those vendors to get it resolved ASAP. And we believe that this approach has actually delivered pretty stunning results as far as the industry is concerned in terms of customer satisfaction, in terms of net promoter score, and in terms of general availability. So we have astronomical CSAT scores. The net promoter score is over 2 times that of any of the larger storage vendors out there. And what we've seen is that we have greater than 5 nines availability across all of the production arrays as of today. And I mentioned this a little earlier. So beyond just the technology, beyond just the people and how we sell, etc., what we're really trying to do is make sure that the customer has the best damned experience with our product ever. So with that in mind, we've introduced a couple of very innovative programs like the Love Your Storage guarantee. In a nutshell, what this means is that if you don't love the array that you bought from us, send it back to us, no questions asked, within 30 days for a full refund. We believe in the maturity of our product and the quality of our product, that we're willing to bet that you will basically love the array that we sell you and have absolutely no issues with it. We've also introduced a couple of other innovative programs like Forever Flash. What Forever Flash does is indemnify you from having to do forklift upgrades or to replace your legacy storage. So essentially, for customers who are under contract and have renewed their support contract, we will ship you the latest generation of controllers every 3 years. And we're continuing to basically introduce these types of programs where it's not just about the technology, it's about how customers actually do business with Pure Storage. And we think that this is one of the major differentiators for Pure compared to some of the other folks in the industry. Here's a good example of a customer who moved to Pure. They were able to see stunning results. Their old storage infrastructure was, they had over 150 terabytes, fitting into about 58 U's. Storage was the bottleneck because essentially spinning disk was not able to support the virtualized infrastructure that they were building out. They had multiple databases, multiple virtualized applications sitting on legacy storage. And because of the limitations of legacy storage, they were simply not able to meet the demands that the business was requiring. As they moved over to Pure, that 150 terabytes was able to fit into a 35 terabyte FA420 system. They went from 58 U's to 10 U's. They saw an 800% improvement in their SQL Server performance. Backups went from 1.5 hours to 10 minutes. And they lowered their overall cost, both in terms of the array itself, but also data center costs, like power, cooling, etc. So that was a little bit of a history about Pure and what exactly we do. So now let's dive into the database section of the presentation. Databases are an extremely key focus area for Pure Storage. Well over 50% of our customers and our deals are related to databases, primarily SQL Server, Oracle, MongoDB, and MySQL. So this is an extremely important area for us, and we're continuing to invest in the technology as well as in the people to make sure that we are ahead of the curve as far as databases are concerned. So if you look at basically some of the needs or some of the challenges that you see in the database environment today, servers and semiconductor-based infrastructure, you see an instance like Flash, you see sometimes like close to a 200% improvement in performance compared to spinning disk. Spinning disk is really, if you look at it, hasn't changed a lot since the 1970s. And it's a physics problem, quite honestly. You can only get that disk to spin so fast. Beyond that, you run into all sorts of issues like wobbling of the disk, which will basically ruin the media. A database instance, whether it be on physical or virtual, suffers because of this, because of numerous issues. Well, performance is number one. If you look at a virtualized database instance, you have stuff like block misalignment, which is a very, very common issue. And random I/O is really toxic to database environments from a storage perspective. So the advantages of moving your database infrastructure to Flash is pretty simple. You have a simplified disk layout. You don't have to worry about the various layers or tiers of storage that you have to place your database files in. For example, you'll commonly hear people say that don't put your redo logs or your temp DB files on Flash. it will not have any benefit. You can do away with those sort of recommendations and complexity and just put everything on flash. Specifically with Pure, we've architected the solution to be almost a plug-and-play device. We guarantee that it will be the simplest storage array you've ever used. We have numerous customers who say that, well, now the database team essentially manages the array themselves. They don't even need to interface with the storage team anymore, just because it is so simple to use. You can use, an example of that is you can use any block size. We write at the 512 byte geometry, so whether you're using 4K blocks, 8K, 32K, 64K, it doesn't really matter to us. It will not affect the performance of your database. Data reduction is also a key component of the architecture. Typically for database environments, we see anywhere from 3-to-1 to 8-to-1 reduction. An added benefit of Flash, because of the performance, the data reduction, etc., is you're able to consolidate your database environment and actually optimize the SQL licensing. Often we find that the database licenses on their own dwarf the infrastructure costs. So that is a huge pain point right now. Database sprawl could lead to basically very, very painful audits from the database vendors. So you can actually help alleviate this by consolidating the environment and actually reining in the costs of your database licenses. And of course, it's Flash, so it's extremely fast. It allows you to do more efficient disaster recovery, dev test, moving from dev test to production very, very quickly. So, in a nutshell, here are a couple of the ways that Flash, or specifically the Pure Storage array, simplifies database administration. And I mentioned this, a few of these points before. You can use any block size. You can use any file system. We don't really care. You can use any number of LUNs. So performance is not a function of the number of LUNs. So you can actually use one humongous LUN, or you can use many, many small LUNs. It doesn't really matter as far as performance is concerned. A common pain point is RAID. So how many times have you heard of arguments between the storage administrator and the DBA about RAID? The DBA says that I want RAID 10. The storage admin says that, well, no, the best we can afford is RAID 5. We've done away with that. We have our own proprietary RAID technology called RAID 3D. It is always on. It is not attunable. It's simply there. You never have to worry about it ever again. Like I mentioned before, no caching or tiering worries. Everything is on Flash. Everything is just always fast. You can easily grow or expand the size of your LUNs as need be. And we make snapshots extremely simple. So to dive a little bit into the weeds, the way we do snapshots is through metadata. So when you take a snapshot off a LUN, you're basically just copying metadata. So it's more or less instantaneous. And the snapshot is its own new volume that you can do operations on. So net, what we're trying to do is accelerate essentially the apps that drive your business. So databases are not the end; they're a means to the end. So mission-critical databases like SQL Server are what you run your business on. So by improving the performance of SQL Server, you're actually basically improving the business aspect. So imagine if you could improve your analytics reporting by 10 times. So what would that mean to your business? What if you could deliver services, new services, out the door quickly in weeks rather than months or years? What would that mean to your end customers? And what would that mean to you from a competitive standpoint? What if you could architect your solutions more efficiently? What if you could basically move from test dev to production much, much faster? What would that mean for you from a business perspective? So those are some of the considerations to keep in mind when you consider moving from traditional storage to Flash. So I've talked for a bunch now, and I really want to pass it over to Kyle to talk about SQL Server in depth. So Kyle, could you give us an idea starting from a very fundamental level about what SQL Server is and why storage has an impact on SQL Server's performance?
I will. So a lot of times when we give webinars, I like to do a lot of education, and generally education starts at the very bottom. So today we're going to be going all the way to the file itself when we start talking about SQL Server. So if you're used to working with SQL Server, you know that SQL Server uses data files and log files. So you have your MDFs and your LDFs. Those two files are what people really recognize when they think about, okay, this is how SQL Server interacts with the file system. If you open those files up, you'll just see what appears to be a bunch of gobbledygook hex stuff. But in reality, that's not gobbledygook. It's your data. It's your precious data, and it is organized. So when you think about SQL Server, it has to be able to find your data. And it does that by having a specific structure around what it puts where within that file. And so if you can think about the storage in SQL Server as a hierarchy, so on the outside we have the file, and then as we move a little bit further in to the hierarchy, we have what's called an extent. So an extent is actually 8 pages. So we're going to move into page in just a moment. But if you can think of an extent as being multiple pages, so SQL Server will group pages together in the file because there are certain processes within SQL Server that access the extent level information. So it's kind of a shortcut for SQL Server to be able to go and get that data. As you move further, you have a page. So the page is kind of the atomic unit within SQL Server. You're going to find as we start talking through this presentation that a lot of what we're talking about is on pages, and there's a good reason for that because it allows consistency within the database. And then within the page we have the row. So if you're used to working with SQL Server and you write a select query and you select star from table and you get a bunch of rows back, those rows would have resided on at least one page, which is part of an extent, which would reside in a file. So the hierarchy works its way up and down this hierarchy, and SQL Server interacts at each level of this hierarchy in different ways. So when we think about data storage in SQL Server, everything is an 8 kilobyte page. So if you think about your phone, it's 16 gigabytes. 32 gigabytes. If you have a fancy phone, it's more. But we're talking about 8 kilobytes is how SQL Server measures things. So a kilobyte here is, if you got a phone, it's 16 gigabytes. That's 16,000 megabytes, and that's 16 million kilobytes. So SQL Server manages everything at this kilobyte level. And so within every page, there's 1 to n rows. So a data page that's being stored will have at least a row on it. SQL Server tries to put more rows on that page in order to get the data out more quickly. And then it writes that to the disk through various other processes. Within SQL Server, you really only have 2 ways to store data, structured and unstructured. And so within structured, there's only 2 ways to store structured data, and that's either in a heap or a clustered index. So when I start talking about a heap, if you're in SQL Server and you just do create table, what you're going to have is a heap. And so what that means is that SQL Server, when it writes data to that table, is going to find the first available spot it can and put the data there. So you can't really anticipate ahead of time where in that file the data may be written because it's dependent upon the point in time the data is written. However, a clustered index, so if you go in Management Studio or you go through T-SQL and you put a clustered index on the table or a primary key leveraging a clustered index, what that does is it puts it in a specific order in the pages on the disk. So it's predictable based upon what value you're inserting, where it's going to go on that big file that you have, that MDF file. Unstructured data is still stored in 8 kilobyte pages, So like an unstructured data here would be like an image. So if you're storing images in your database, or you're storing an XML blob, those are still put onto 8 kilobyte pages. But generally once the size exceeds 8 kilobytes, then there's a tree of data that gets linked back up into that row, and then there's a bunch of 8 kilobyte pages supporting these files that exist. One way I like to tell people is this is kind of like a phone book. So if I have a phone book and you're flipping through it and it's organized physically by last name. So in this case, that would be the clustered index. So we have our phone book, we have pages. So we open up a page and there's 200 phone numbers on there, or 1,000, however dense they may put it. There's 200 phone numbers on that page. So those represent our rows. So we have a phone number, and then we have a bunch of phone numbers on a page. And then when you think about the phone book, it may have two sections. You have kind of the yellow and the white section within the phone book. That's what I call the extent. It's not an exact representation of an extent, but it helps you understand the logical separation between extent, and then the whole phone book itself is your MDF file. So when you think about how SQL Server stores information, it really stores it in the hierarchy similar to how a phone book works today. A lot of times when I give this presentation physically, I'll have a phone book with me and I'll open it up, and a lot of times I can't even find a phone book anymore. So I'm hoping that in 5 years people will still understand my analogy, but as of today, people still get the phone book, so that's the analogy that I use. So what's all this talk about disk? RAM is very important to SQL Server as well. I say all the things must pass through RAM. Nothing in SQL Server can be done without anything passing through RAM first. So when your computer is shut off, everything's on your disk. When you turn the computer on and SQL Server loads up, it starts bringing stuff from disk into memory. So if you have enough memory on your box that SQL Server can load up all that stuff, it operates in memory and then only relies on disk for making changes. Not many people have that luxury of being able to have an entirely memory resident workload. So what will happen is that SQL Server uses a modified, it's called least recently used algorithm for SQL for what it stores in memory. So let's go back to our phone book. If I'm looking through my phone book and I have filled up my memory with all the pages of the phone book that I found phone numbers for, if I want to go get a different page, then what SQL Server has to do is it has to take one out of memory, write it down to disk, then go to disk and get that other one back up as it needs it. So sometimes you'll have a little bit of churn, and if you run a big query that has a bunch of data in it that didn't exist in memory and your memory is already full, it could actually flush your entire RAM and pull everything from disk to satisfy that query. And that's where disk becomes important, because a lot of times since you don't have the luxury of having a memory resident workload, you're relying on that disk I/O with it, as Avi said, hasn't kept up with the other components of the system. So if you've got a CPU from 10 years ago sitting next to a disk from 10 years ago, and then you compare that to a CPU of today sitting next to a CPU, or a CPU from today sitting next to a spinning disk from today, if the difference is about 300 times different between the CPUs, and it's almost the same between the disk and the older disk. So the technologies haven't really kept up with the disk, with the spinning disk, and that's really where the solid state comes into play. So we've talked about how SQL Server stores data, and we talked about why it cares about the disk. So how is it interacting? So how's it interacting with the disk when it does read it? So we've decided it has to read it, which is great, but how does it do it? So there's really only two ways. There's other ways, but for the purposes of our talk, there's really only two ways that SQL Server can read data. The first way is random. So if you can think going back to our phone book scenario, and let's just say that I want to go get some phone numbers spread somewhere throughout that phone book, and I'm just flipping pages. So I'm opening up page 8 and getting a phone number from there, opening up page 250 and getting a phone number from there, and so on and so on. Those are random reads, because what it's doing is it's going through, getting a tiny piece of data and moving on to somewhere else in the database to get another tiny piece of data. The other method is sequential. So if you can think about sequential as I'm starting at a certain point in the phone book, and I'm grabbing every number until I get to another certain point in the phone book. So with sequential reads, it's able to really keep the disk from moving around. It's actually issuing a sequential read to say, okay, disk, don't find the other data. Just start here, give me everything until you get to here, and then be done. Random reads, and Avi was talking about, it doesn't really matter what you do, what your block sizes are on your disk, and I would agree with that, but that doesn't change the way the SQL Server behaves when it does write the data. So your random reads and writes are always going to be in 8K to 256K chunks. So if you can think about, I have an 8 kilobyte page. Every time SQL goes to get a read that's random, it's going to be somewhere in that range between 8, a single page, and 256 kilobyte chunks. So grabbing a 256K chunk at a time. Then we have sequential reads. So those will start at 8K but quickly move to 256K, much quicker than the random reads will. And that's called read ahead. So what SQL Server does is it tries to anticipate, hey, I'm going to be scanning a bunch of data, and it tries to predict, okay, I need to go ahead and get all this data ahead of time because you're going to need it in a minute anyway. And so what it will do is it will find chunks of data and load larger chunks at a time in anticipation of you needing it in a moment. That is that's something that lends itself more towards spinning disk, because spinning disk latency is your issue, but it can read data relatively quickly. So once it finds that spot on the disk, it's able to get the data off of that spot with relative speed. If you're on Enterprise Edition, it gets kind of interesting because now it can actually go up to a full megabyte read on your sequential read. So if you think about when people talk about IOPS, that's I/O operations per second. So every operation, if I'm getting an 8 kilobyte read, is only getting 8 kilobytes. So if I have a 4,000 IOPS system, then I'm only able to get 32,000 kilobytes per second. However, if I'm issuing larger chunks of reads, it is not a linear ratio, but a lot of times I can move more data on a spinning disk system if I get larger reads at a time. We're going to talk about here in a moment where that doesn't really matter with a pure flash system, but understand that's why these mechanisms exist in SQL Server, is to compensate for the spinning disk technology. And one thing we'll talk about is sequential writes, which are 8 kilobytes to 60 kilobytes. So your log file, when it does those when it flushes that log buffer, it's actually writing in 60 kilobyte chunks to the disk every time. When we start thinking about SQL Server, the developers who have written it have done a great job compensating for the I/O difference. So we talked about how we have CPUs from 10 years ago versus CPUs now, and then disks 10 years ago and disks now. Because CPU has well surpassed the disk technologies, Microsoft has put in several features that help to compensate for I/O. And I've put these in order in my mind of just kind of the value you get when it comes to pure I/O. These may not have the same order for your environment, but as it comes to raw theoretical I/O, this is kind of where you're going to see a difference in how SQL Server compensates for I/O. So we're going to talk about compression here. With compression, what happens is that SQL Server will takes the data that you get, and it runs a compression algorithm on it in memory, and it stores the compressed data in memory. And when it writes it to disk, it's compressed. So before it ever hits the disk, it's compressed. So you can end up, remember how I said all the things must pass through RAM? If you have SQL Server compression enabled, then you can sometimes I've seen cases of 8 times the amount of data into memory. And so you can tilt that scale of memory resident versus not memory resident towards the memory resident side by enabling compression. It also reduces your footprint on disk and reduces the time it takes for the stuff that's not in memory to come up from the disk. So that's compression. Partitioning, what this allows you to do is as Avi alluded to, in the complex world of spinning disk, it allows me to dedicate chunks of disk to different types of data. So both tiers and both scaling out. So I could have a partition table that allows me to keep my most recent data in the SSD tier, and then I have the last 6 months data in my SAS tier. Then I have all my historical data down in my SATA tier. So it allows me to create partitions and to manage at a very granular level what data goes in what tier. So as far as spinning disk technology is concerned, this helps me to, as a DBA, to make certain that the stuff I need to perform is sitting where it needs to be in order to perform. So indexes. Indexes is an interesting one, and you'll notice there's no asterisks on indexes. The asterisk is Enterprise Edition only. So the first two technologies that we talked about, and the last one, Columnstore Indexes, we'll talk about in a moment, you have to have SQL Server Enterprise Edition. So if you want to take advantage of these I/O compensators, Microsoft has bundled those into the Enterprise Edition, not the Standard Edition. However, indexes, while they've been around for a very long time, are functionally an I/O compensator. Whether it's in-memory I/O or disk I/O, they're compensating for I/O because they're preventing SQL Server from having to look at all the data. So if you think about an index, if like our phone book example, it's organized by last name. If I wanted to go find all the Kyles in a phone book, then I would have to go and look at every page, scanning every page for every Kyle and recording the location of every Kyle that I came across. However, if you can think about if someone was nice and put an index in the phone book that had a first name mapping, and it said that, okay, for every Kyle, he's on page 12, 18, 46, and 53. So the index allows SQL Server not to have to look at every page to get the data. And a lot of times you can create an environment where the base table itself is never even accessed other than for writing data. So you can have all of your reads coming from indexes and significantly increase your performance coming off of disk. And then we have column store indexes. So with column store indexes, this is fairly new. What this does is if you've ever heard of Microsoft talking about the VertiPack engine, or talking about Power Pivot, or talking about the tabular data model in analysis services, the column store indexes work in a very similar way. What happens is that with SQL Server, the normal storage is row-based. So if you think back to the phone book, if I have 1,000 Nayers in the phone book, then that word Nayer is on every row. And so while compression can compensate for some of that, it still has to allocate space for every row that Nayer exists. Well, with column store indexes, what it does is it puts all of the same column value on a page and tells you where they are. So that it's kind of like saying that every column is on a different page for every row, and then SQL Server materializes that back into a row view when you select from it. This has a significant advantage for aggregate queries, so data warehouse queries that I'm trying to get averages or sums, because SQL Server can go to much fewer pages because it doesn't have to know what rows each of those values belongs to, because all it's doing is an aggregate. So it doesn't have to know the details of this value belongs to this row and this value belongs to this row. It just needs to know how many of what value exists to make those aggregate values count. So column store indexes significantly compensate for I/O and aggregate queries. So we're talking about pure storage. So I'm going to go back through real quick and talk about how Flash changes the game on some of these things. So with our SQL IO compensators, compression. I will almost always still do compression if you have Enterprise Edition, even on a Flash array, because memory is faster than Flash. Even though Flash is super duper fast, if it's in memory, it's significantly faster. So if I can fit more stuff into memory, then I always do compression. However, even with compression, I still have to get that data up from disk. And the more stuff I fit into memory, the higher likelihood it is it's going to be random and not sequential reads when it goes to get it. So as I compress my data and I have a flash array behind it, I don't have to worry about the latency that I would used to see on spinning disks, because now as SQL Server goes to get that random I/O, it doesn't have to seek on that spinning disk. It gets it immediately, and there is very little latency to get that data. So I will still do compression as a performance technique within a SQL Server environment on a flash array, but it in and of itself is less necessary if you're more disk bound. But all it does is keep more stuff in memory, which keeps it closer. So if you can't get enough memory to make a difference, flash has a significant impact. But if you can get enough memory to make a huge difference, and you can do Enterprise Edition of SQL Server, and you can compress the data, then you can sometimes not get as significant benefit out of a flash storage array. But the benefit is always there, and there was a lot of caveats there in order to not get as much benefit out of the flash array. Partitioning. So partitioning, I will still only use on a flash array for logical reasons. So with partitioning, I can use the sliding window functionality where I can easily switch in partitions as I'm loading them through an ETL process, or I can switch out partitions as they archive out. So in that case, it has nothing to do with performance. It has more to do with the logical creation of the data. So in that case, I still do partitioning, but with the flash array, I don't do it for performance. There's some maintenance reasons I might do it, because I want to only rebuild indexes. I want to only maintain my indexes or stats at the partition level. But once again, that's not a performance reason as much as it is a maintenance reason. So as far as partitioning goes with the flash array, it's not really that helpful, because as Avi pointed out, it doesn't matter if you have 1,000 LUNs or 1 LUN, you're getting pretty much the same performance. Pretty much. They're at the fringe where you have a bunch of LUNs, SQL Server starts to change the way it behaves. But generally speaking, you get the same performance regardless of how many LUNs you have. Indexes, always use indexes. Always, 100%, always use indexes. I don't care what storage you're using. Always put indexes, and I will say, unless it's a very rare case, to always have a cluster index on every table. There are certain cases where not having it does improve the performance, but they're very rare and very well documented if you want to research those. Columnstore indexes. So this is more about improving in-memory workload. So once again, yes, still use them, because your aggregate queries will be a lot faster. Because if you could think about this, even if you have a flash array, let's just say that flash array is super fast. So I'm able to move 150 megabytes per second. If I can avoid moving 150 megabytes and only have to move 240 kilobytes, it's going to be faster, regardless of what system you're using. So with Columnstore Indexes, it allows those aggregate queries to be significantly faster over time and cause less stress and CPU on your server itself. So all of these are I/O compensators, and they can all still be used when you're working with a flash array, but their purpose has kind of diminished as you move into the flash space. So that's I/O compensators. We still use them every day, but that's one of the advantages you'll get with when you talk about the benefits of pure storage and a flash array, is that simplification that you have of not having to do funky stuff for performance. So a lot of the things I think about when I think, why would I want a flash array? Why would I want pure storage? I don't have to worry about arguing with the storage admin. It was funny when I heard when I heard Avi say the DBAs aren't arguing with the storage admins anymore. I've had to have heated arguments with storage admins before, because we were under pressure to make the database perform, and they were under pressure to squeeze every ounce of storage out of their SAN that they could, and that's a constant conflict. And with Flash, that conflict just doesn't even exist. So that's probably the best non-technical benefit of having pure storage. The performance boosts. So response times for latency for random reads, it comes down. When it's doing sequential reads, it's better, but you really see that huge benefit if you're dealing with random reads. Running multiple workloads. So running decision support. So you have your queries, and you have for your reporting, and then you have your people doing your transaction system. In spinning disk world, we have to separate those for performance. In flash world, we don't necessarily have to separate those for performance. We may want to separate them for other reasons, whether it be logical separation or permissions or security, but we don't have to separate them for performance because everything is going to be the same speed in that environment. One thing on here is cost efficiency as well. I will say that the data reduction is real. I have seen it myself. And I will also say that even with a compressed SQL environment, there is still data reduction. I don't know what magic spell they're casting in there, but even when I do have a compressed database, they are still getting some reduction. We're not talking 10 to 1 here, but there is some reduction when we're talking about how we're storing that data onto the disk. And then the backup copies are amazing. Very quick to spin up, quick to use, and we don't have to worry about doing backups and restores anymore with this technology. So with that, that's really how SQL Server leverages I/O and a little bit of understanding about how it works. So I'm going to hand it back over to Avi, and he's going to wrap us up.
Thank you very much, Kyle. That was very, very informative. I actually learned quite a bit from that. But just wrapping this all up, I think the best way to basically wrap it up is to talk about actual customers and what they've seen with using SQL Server on all flash. Here's an example from People Finders. So, and here's a quote. They essentially say, I'm paraphrasing, they're essentially saying that we've changed the way that they do business. And that's really what the goal of infrastructure is, right? Infrastructure is meant to support the business. Infrastructure is not an end to itself, it's a means to an end. So our goal is to basically help customers change the way that they are running their business. People Finder moved off of their old legacy array onto Pure. They were basically able to decrease the amount of time it took to do certain reporting aspects from 2 months to a couple of hours. Batch jobs that could take up to 72 hours were reduced to 32 minutes. Analytics jobs, which took 42 hours, were reduced to 28 minutes. All of that is great from a technology perspective, but from a business perspective, it's transformative, right? Imagine now if you were basically able to cut down the time to analyze your end customers' needs. Imagine if you have a social media program. How long would it take you to mine data from social media to actually have an impact on the business? With legacy storage, it would take too long, let's just say that. With Pure Storage, you are able to actually usefully mine the data and put it into action. Another example is TripPack. So TripPack is actually a part of the Xerox company, and they're a large logistics company. So they have a huge virtualized environment. A lot of that environment is SQL and Oracle. Immediately after moving to Pure Storage, they were able to see over almost a 30x increase in the IOPS. They were capped at about 7,000 IOPS. Immediately after moving to Pure Storage with very little tuning, they were able to get 200,000 IOPS. Now, that's impressive performance, but when you're talking about performance, it's not just how fast you can go, it's can you maintain that? So consistency and predictable performance are just as important as the raw performance you get. What this also allowed TripPack to do was essentially virtualize the last portions of their physical estate and move it into the virtual environment. They were able to see about 4-to-1 data reduction for the database environment, Oracle and SQL. Last example here, Mattersight. So they're an analytics company. So basically what they do is they capture and analyze millions of human interactions across the web, multiple channels on the web, and try and mine that for valuable insights. So they had 100 terabytes on traditional arrays, found that I/O was the bottleneck, found that their bread and butter, which was doing analytics, was just taking too long, days in fact. So after they POC'd the Pure Array and actually moved their production systems onto Pure, they found basically the analytics processing that was taking them over a day to perform was now being done in under a couple of hours. Application performance overall improved by 50%. We're seeing 9-to-1 data reduction. 70% of the I/O workload was moved to legacy Tier 2 arrays. Moved off of legacy Tier 2 arrays, sorry. So essentially what we're seeing is customers are moving their most important essential stuff onto Pure and putting their Tier 3 applications onto traditional disk, because a lot of customers have made investments in that. So as they're phasing out legacy storage, they're basically moving all the important stuff onto flash like Pure and moving all of the non-essential applications onto legacy until they phase that out, and then everything goes on flash. Again, they're in the process of moving the extremely large VM environment, I think it's a vSphere environment, onto Pure Storage. So these are just a couple of examples of how flash has not just improved the infrastructure of businesses, but they've had a transformative impact on the business itself. So with that, I think we come to the end of our presentation. I really want to thank Kyle and Apparatus for having me co-present with them. They are an extremely important partner for us and a valuable resource, especially when it comes to databases like SQL. So thank you very much, Kyle. And I think we can open it up to Q&A.
Okay, it looks like we don't have any questions. I'm going to go ahead and wrap things up. Avi and Kyle, thank you for presenting today. Following the conclusion of the webinar, we'll be sending you a video of the presentation so you can keep. And in the next couple of weeks, we'll also be sending you a Pure Storage ebook, so look out for that. And thank you for attending.
Thank you very much.
Yep, thank you guys.